This will be for the con exercise, scale functions vertically. All right, so we'll start by letting k be a constant, and we take the function f of x and we multiply it by k. Okay, if k is greater than -1, the graph is vertically stretched. Okay, that just means it increases faster. And if k is between 0 and 1, the graph is vertically compressed. That just means it increases slower. Okay, I don't think on any of these we'll be multiplying by -k. So I just use these two examples. All right, but just as an example, if k were 2 and you did 2 times f of x is the y values, and multiplying the y values by 2 will make the function increase twice as fast. Okay, and on the other hand, if you took f of x and you multiply it by 1/2, all of the y values will be cut in half. Okay, and the graph won't increase as fast. In fact, it'll only increase half as fast, so it'll be more compressed. Okay, and you'll see examples of that in a moment. All right, first problem, f of x is x to the third plus x squared, and g is a vertically scaled version of f. The functions are graphed where f is solid and g is dashed. All right, so the one in blue is the original one, and the dashed line is the new one. And they want to know what is the equation of g. All right, let's look at the graph first. And it's really not too difficult because they lay out the points for you. Okay, if you look at the original function in blue, and they give you one of the points right here. All right, this is x equals 1. But the x value doesn't matter. It's just that these points are at the same x value. Okay, at x equals 1, the original point is at y equals 2. Okay, and the new point at x equals 1 on the new graph that's in pink, the y value is at x equals 5. Okay, so 1, 2 ends up being 1, 5 on the new graph. All right, so in terms of multiplication, how do we get from 2 to 5? So basically, we're saying 2 times what? We'll call it k equals 5. Okay, and if you divide both sides by 2, the 2's cancel, and k is going to be 5/2. So the whole function is multiplied by 5/2. Okay, you can test it with another point if you want, but really they give you this point for a reason. All right, the whole function is multiplied by 5/2. So if we pull up what they gave us right here, okay, this is f of x. We're going to do 5/2 times f of x. Okay, and that 5/2 will get distributed to each term in the original function. So this here, instead of x to the third, it's going to be 5/2 x to the third. And this here, instead of positive x squared, is going to be positive 5/2 x squared. Okay, so like I said, the 5/2 got distributed to both terms. So this will be the answer, and we just have to find the choice with that answer. 5/2 x to the third and 5/2 x squared. That's answer D. All right, once again, function g is vertically scaled version of f. F is solid, g is dashed. All right, so blue is the original, the pink one is the new one. And it says, what is the equation of g in terms of f? All right, so again, we just have to find out what multiple they used. All right, and these points are both at x equals 4. All right, so I'm just going to write this out. And the original one, the y value, if we trace it across, that's at 3. And the new one, if we trace it across, that's at 6. All right, so how do we get from 3 to 6 in terms of multiples? Basically, we're asking 3 times what equals 6? Well, of course, k is just 2, okay? They're multiplying the whole function by 2. And that makes sense. See the one in pink? It is vertically stretched because it's going to increase faster because it's multiplied by 2. So whatever f is, g is just going to be 2 times f. Okay, that's the multiple there, 2 times f. And the choices will probably say f of x. So if we scroll down, it's just 2 times f of x. All right, this is the graph of function f of x equals log base 2 of x. What is the graph of g of x equals 1/2 log base 2 of x? All right, so notice they took the original log base 2 of x and they multiplied it by 1/2. So all of the y values are just going to be cut in half. They're going to be multiplied by 1/2 or divided by 2. All right, so we can quickly sketch this. All right, on this point right here, y equals 0. Okay, 0 times 1/2 is just 0. So that one's still there. This point right here is at y equals 1. Okay, and of course 1 times 1/2 is just going to be 1/2. So this point, instead of being at 1, is going to be halfway there, about 1/2. Okay, and at x equals 4, y equals 2, and of course 2 times 1/2 is just going to be 1. So at x equals 4, the new y is going to be right there. All right, so it increases more slowly because it's multiplied by 1/2. So it's actually compressed. And let me see, down here, instead of this point being at -2, it's only going to be at 1. So you don't have to do this part down here, but it's basically going to be like so. All right, anyhow, just check the options at 1, 2, and 4. It's going to be at 0, 1/2, and 1 when we scroll down. Okay, we're looking at 0, 1/2, and 1 for the new points. This is at 0, this is at 1/2, and this one is at 1. So I'm pretty confident it's A, but let's double check. This one's not at 0. This one's at 0, and now it's at 2. So that one's wrong. And this is at 0. This is like 1/4, and this is like 1/2. That's no good. Okay, so clearly it's answer A.